Okay, welcome to the collab for week 3, day 4. You found this link because you went to Cursor, or you went to the README, or you went to any one of the million other places where you'll find a link to this collab. But hopefully you've got it. Week 3, day 4. We're going to be looking at the low-level API to the Hugging Face Transformers library, working with models directly. They wrap the PyTorch code that actually goes through the layers of the neural network. We're going to be looking at that code. Remember, if you get some sort of funny CUDA error, then disconnect the runtime, connect to a fresh T4, start again from the top. And over here, you should have connected to a T4. It should say connect to hosted runtime T4. You should be able to view the resources, and you should see the GPU RAM. It should be nice and fresh. 15 gigabytes left to fill, and today we will fill it. The first thing to do is to run these pip installs, and they will take a minute. Even on quiet mode, it still insists on being talkative. We are installing a couple of libraries here. Bits and Bytes is the name of Hugging Face's library, which deals with quantization, with the topic that I just yabbered away about for ages. Accelerate is also like a companion library that is to do with being able to run efficiently on GPUs. So we bring in both of these, and we are then going to, as usual, bring in a few... import a few packages that we need to do, and then we're going to sign into Hugging Face. But remember, you need to go to the key here. You need to turn this on, or it'll prompt you if you don't, and which is fine. You can just say yes, and then come here, run this so that you log into Hugging Face. Okay, so just to talk for a second about having access to the Llama models. So yesterday, if you followed my instructions, you will have got approval to access Llama 3.1. Now today, I'm actually going to use a different model, Llama 3.2. And I think in some situations, you have to ask again to have access to this, or you may already have been granted access. But if you click on this link, it will come up. So click on this link right now, go there. It's going to come up, and I see that I've been granted access to this model. You may have to do the same. Maybe you have to ask again. Maybe you already got access. If you have to do it again, feel free to just use 3.1. It's a bigger model, so it's going to take longer for you. And 3.2 is much quicker, much smaller. But you should do whichever one you want. And if you weren't given access to Llama, then just skip the Llama section of this and do the others. Okay, and so with that in mind, here are the names of the models we're going to look at today. We're going to look at Llama. I've got 3.1 and 3.2 in here. You can see that 3.2 is going to, I'll comment out this line to avoid confusion. If you want to use 3.1, uncomment that line. There's Llama 3.2, and then we'll also look at 5 from Microsoft, 5.4, Gemma 3 from Google. We're going to go with the really tiny one, the 270 million parameter one. Tiny Gemma. And then Qwen, we're going to use Qwen 3, the 4 billion, so a medium size, quite big. And we're using the instruct variant, the chat variant, and the one that's for me anyway, fairly recent, a few months ago. I believe that's meant to be 2025 and July. So whatever, 4 months ago. Then just here, we're also going to use DeepSeek because, DeepSeek is cool. And we're going to use the version of DeepSeek that was distilled into Qwen. Remember how I explained that? They trained Qwen with data produced by DeepSeek. And we're using the 1.5 billion variant of Qwen, a small Qwen. So these are small models. But the important point is that these ones are all instruct variants, chat models, designed to have user assistant. Qwen, this one here, DeepSeek distilled into Qwen, is a reasoning model. So it's going to be our first experience running a reasoning model through the code. So these are the models. I will run that. And now this is going to be our message. It's going to be tell a joke for a room of data scientists. A nice and simple message that we've got from them. Got from them? I mean, simple message we got for them is right here. Okay. So, we are now, a quick reminder that you need to accept Meta's terms of service. If you haven't already, I'm sure you have. But if not, then do follow the instructions just as before. And if you have problems with Meta, then do go to this troubleshooting collab. Okay, let me see. What we're now going to do is build something called a bits and bytes config. So this is where we specify what kind of quantization we want to do to reduce the precision. And so It's Bits and Bytes, which is a sort of jokey name. It's meant to sound like bits and bytes, but spelt the geeky way for 8 bits. So we're telling it that we want to load in 4 bits. We want to reduce the precision all the way down to 4 bits. This is like an extra thing which allows it does it 2 times and for extra efficiency. You can look up why that works well. And then this here is the important one. This is where we say we want to use this NF4 data type. This data type which we're not going to interpret these 4 bits like a number from 0 to 15, but rather we're going to map these 4 binary bits into some normally distributed floating point number. If you know what that's all about. So we'll run that. Okay, now this is where we are going to now create our tokenizer. Same code as yesterday. We're going to do from pre-trained for the llama model. This line here is just something that you have to do, and you always see it in the code. It's some fiddly thing that the tokenizer has some special tokens. We saw them yesterday, a bunch of special tokens. And one of them is the end of sentence token that comes at the end of the sentence, EOS. And another of them that Hugging Face expects is called the pad token. And it's one that Hugging Face uses to add extra spacing if it needs to. And for some reason, most of these tokenizers don't have this set, and it needs to be set by default to be the end of sentence token. And if you don't set that, then you get an error somewhere else. So you'll see this in the code everywhere. People do this. And I wonder why they don't just put this as a default somewhere to avoid it. But for whatever reason, you see tokenizer.pad token equals tokenizer.eos token. So we just do that. And then we do tokenizer.apply chat template. We pass in the messages that we just did, and we want to put this on the GPU, something we didn't do last time. But because we're going to run it, we're going to take these tokens that we're going to make, these token IDs, and we want them to be sent off to the GPU because we're going to run fast matrix maths. And so you have to know that first of all, you have to have this converted into PyTorch types of data structures, which are ready for the GPU. So this return tensors equals PT stands for PyTorch. It's very, very technical, but you need to do that. If you don't do that, there'll be an error. And then you do to CUDA. Remember, CUDA is the name of NVIDIA's GPUs technology. So that's saying, please go and push that onto the GPU. This is all, if you're thinking, how am I going to remember all this? This is super standard. You see this everywhere. It's one of those things you just do it this way and it will just work. So we do it now, and as I promised you, it will just simply work. That's happened. We got the inputs. They are now sitting there. Let's have a look at them. Hang on, code. If we look at inputs, here it is. This is like a PyTorch tensor. A tensor is basically a fancy name for a matrix, essentially. And it's a matrix of numbers, and it's sitting on our GPU. And that is what we've just built here. And I know I'm not giving you like super detail on this, enough so you get some intuition. You don't need to be able to know this back to front. Okay, so next up, you remember the way we created a tokenizer just here? We're going to do a very similar thing to create a model. So here it is. We're saying we want to use, just like we used auto tokenizer before, we're saying auto model for causal LLM. A causal LLM sounds like a bit of a mouthful. First time we've heard of this. It just turns out that's the name that Hugging Face gives to LLMs that generate content the way that we do. They're called causal LLMs. There's another technical name that some of you may have heard of called autoregressive LLM. It's a name for one of these things where it spits out a token and you put that back in and run it again, that kind of generation LLM. So the general word that Hugging Face gives for it is causal LLM. These days, when people say LLM, that's all they're referring to. There are other things that are like encoders and stuff, but you normally would then describe that differently. So causal LLM and just LLM. For pre-trained, so it's saying we want the one for llama. This is saying pick what. This is basically going to pick CUDA because we've got a box with a CUDA on it, and we're passing in our quant config. I should run this because it's going to take a minute. It's now going to go off and download the files from Llama. If you pick Llama 3.1, this will now take like 5 or 10 minutes. I think Colab used to have a stronger network connection, but Google might be saving some money, and it takes longer these days. Even this much, we're using a really small Llama here, 1 billion parameter Llama. It's still going to take a while. It downloads the full precision, and then it reduces the precision for what it has in memory. So that's all going to go on, and I will see you in the next video when it's happened.